Hello chemists, today we're going to do our lab on solution concentration using Powerade solutions. The objective of this experiment is to make qualitative and quantitative observations about different solutions of Powerade. Different concentrations of Powerade solution are going to be made with water. How we measure concentration in the laboratory is going to be in molarity, which is commonly abbreviated mole over liter or capital M. Molarity means moles of solute per liters of solution. So we need to make sure that the volume is always measured in the liter. To prepare a solution of known concentration, if we know the volume, we can multiply the volume by the molarity, that will cancel out the liters, and give us the moles of solute. And then, using molar mass, we can convert the moles of solute to gram that we can measure on the balance.
So we're going to be talking about the Powerade intro today, and what we're going to be talking about is why we're doing this particular experiment. When we talk about our Powerade lab, we're really looking at some interesting features about that Powerade. So we're talking not only about why are we looking at this particular solution, which is a really interesting solution for us to be looking at, but we're also talking about what kinds of things are we looking at about that particular solution. This experiment was meant to be mostly a qualitative experiment, so just looking at what are the properties of this material that we can see without making any actual measurements about it. But we decided that we wanted to actually make some actual quantitative measurements as well. So we wanted to start looking at what are some things that we can measure that have some actual numeric values that go with them. So we started with our qualitative measurements, i.e. what color is this? How dark is it? How light does it get when we make different dilutions on this particular solution? And then we wanted to talk about how we do different dilutions of that solution. So we do that in two different ways. One, we do it in serial dilutions, where we make one solution, take part of that, dilute that, and then take that solution and dilute it again. So that's a serial dilution. We then also do parallel dilutions, where we take one solution and dilute that different ways. So we take one part of that solution, dilute it to one concentration. We take that solution and then dilute it to a different concentration. So that's a parallel dilution. So we're diluting it to different concentrations. So that's a different way for us to be able to do that. And we want to do the same concentrations for each of those, to do comparisons of them to see if they come out the same. They should, but do they actually? So we want to make qualitative comparisons to see if they look the same. And then we want to actually make quantitative comparisons to see if we get the same numbers out of them. And so those quantitative comparisons that we're going to be making are based on the conductivity of the ions that are in that. So Powerade actually has ionic conductivity from like the sodium chloride and the potassium chloride that is inside of it. So those ions are able to conduct electricity. And those are the ions that we're going to be measuring with the conductivity of those particular things. So not only are we going to be making qualitative measurements in terms of what does the solution look like, but we're also going to be making qualitative or quantitative measurements in terms of how much absorption does that particular solution have. So we're looking at how much light goes through that solution and how much light is being absorbed by that solution. So as the light goes through, some of it is absorbed by that color. And of course, the darker it is, the more the light is absorbed. So as it goes through, we get less of it that gets through there. And so we want to make measurements about that particular solution. So the darker it is, the less we get through it, and therefore we should be able to look at what is that quantitative effect. I keep tripping over my words today, sorry guys. So that's a quantitative effect that we can actually look at. So we're making both quantitative measurements and qualitative measurements for both of those things. So that's what we're doing with that particular experiment. So that's everything I have to say about that. Thanks, guys. So we've got a couple of experiments where we specifically need to be worried about our glove protocols. And those experiments are the solution concentration, the titration standardization, and the titration for the vinegar concentration. So when we talk about those experiments, it's absolutely necessary that we wear gloves for the entire experiments. For the other experiments, gloves are recommended. They're not necessarily necessary. It's never that we don't want you to wear them, but you don't have to wear them for the other experiments. For these, it's necessary. So I want to show you how to properly put on a pair of gloves, how to take them off, and then talk about what are proper protocols for using those gloves in those experiments?